So for this question, what we have is finding the acceleration of the photographer. So that's given here on the graph and also in the text. So the first part is what's the acceleration. So acceleration is equal to v minus u divided by t. That's the definition of acceleration. So we're going to use that, and then we find that it's 35 minus 10 over 150, and that gives you 1/6 meters per second square. For part B, see the part B, it's asking you the time that the photographer takes to catch up with the celebrity. Now, from the time that they meet, from the time that they cross from the time that they cross the path initially to the time that they meet again, their displacement must be the same, or the distance must be the same. Distance that they cover must be the same, that they travel. So therefore, what we have is the displacement of the photographer must equal to the displacement of the celebrity. Now the equations of motions that we have are v is equal to u plus at, s is equal to ut plus half at squared, and v squared is equal to u squared plus 2as. We also have s is equal to u plus v divided by 2t, and s is equal to vt minus half at squared, which I'm not going to really use. So it's the three main equations for me. So then if the displacement have to be the same, then of course what we have is we just work that out. Now which equation can we use? We can't use v is equal to u plus at because we don't have displacement in it. We can use s is equal to ut plus half at squared, so we'll do that. Ut plus half at squared, and then we also have the set for the celebrity, it's going to be the same. Now we don't use v squared is equal to u squared plus 2as because there's no time in it. We want to have an equation which has both displacement and time, because the displacement will be equal, so therefore we can equate those two equations and solve for t. So sp is equal to ut plus half a squared. Now u is 10 and t, we call it t for now, half. Acceleration is 1/6 and t is t squared. For the celebrity, we have the displacement as ut. Now u is 20t, but acceleration is 0, so that's 0. So sc is 20t. Now the displacement for the photographer, simplified, that is 10t plus t squared over 12. So we equate those two together because they are the same. So then we get 10t plus t squared over 12 is equal to 20t. And simplify that further, we get t squared over 12 is equal to 10t. One of the t will cancel out, so you're left with 10 over 12 is equal to 10. And therefore, t is equal to 120 seconds. For the second part, what you have to do, I mean, for the next part, what you have to do is just have to find out. So you're going to find out how far they travel. So just substitute in one of the equations. So sc was ut plus half at squared, but there was no a, so it was just ut, and that was 20 times t, so that's 20 times 120 gives you the answer that you are looking for. That's 24 meters. That's the displacement. So that's the time it will take to catch them both. And yeah, but I think that's the main one. This is the main one. Once you solve this, the other one becomes easy. Okay.